Hello viewers, welcome to Chemphilic. I am Dr. Mala Das Sharma, a retired professor of St. Pius X Degree and PG College for Women, Hyderabad. Using the platform Chemphilic, I am going to teach different topics of all branches of chemistry by adopting a self-designed innovative teaching methodology that is teaching chemistry through riddles. For this video number 8, two important organic reactions are chosen for discussion. The primary objective for making this series of videos is to generate interest in chemistry among the students. The video will be useful for the students who are pursuing undergraduate course with chemistry as a subject and also the students who are preparing for entrance examinations after their 12th standard or intermediate course. Hope students will enjoy. Now, here is our riddle number 8. X and Y are two organic reactions given by same class of organic compounds. Both the reactions occur in presence of alkali solution. While the presence of a particular hydrogen atom is essential for reaction X to proceed, the absence of that hydrogen atom leads to reaction Y. The reaction X condenses two molecules and reaction Y converts two molecules into the molecules of two different homologous series. The final product of reaction X responds to Beer's test. So, this is the riddle. Now, we see the questions. The primary question is, what are X and Y? The other questions are, number 2, which particular hydrogen atom and class of compounds are referred here? Number 3, what is the final product of reaction X? And number 4, what are the products of reaction Y? Now guess the answer of the primary question. The primary question is, what are X and Y? And the answer is X, Aldol condensation, and reaction Y is Cannizzaro reaction. So this riddle is framed to teach the two important reactions of carbonyl compounds. Number 1, Aldol condensation. Number 2, Cannizzaro reaction. Now what is aldol condensation? Here two molecules of an aldehyde or ketone containing alpha hydrogen atom, this is the most important part, combine itself in presence of dilute alkali to form beta hydroxyaldehyde or beta hydroxy ketone. Now look at here, acetaldehyde, it contains alpha hydrogen atom. Alpha hydrogen atom means hydrogen atom attached to alpha carbon atom. Alpha carbon atom means which is attached to this functional group. Now acetaldehyde contains alpha hydrogen atom and two molecules of this acetaldehyde undergo condensation reaction in presence of alkali to form beta hydroxy carbonyl compound. This is the functional group. This is alpha position. This is beta position. So beta hydroxy carbonyl compound. Now similar condensation of two molecules of ketones also considered as aldol condensation. In that case, the product contains the keto group and the hydroxyl group. Now, let's see the mechanism of aldol condensations. In alkaline medium, this hydroxyl ion takes one of this hydrogen atom, that is H plus, from this aldehyde molecule. Here we have taken this acetaldehyde and this carbon ion is formed. Now this carbon ion attack the carbonyl carbon atom of another aldehyde molecule, and then what happened? This pi bonded electron pair shifted to oxygen and you will get this one. And finally what happened? This negatively charged oxygen gets protonated by taking proton from water, and you will get the product, that is the beta hydroxy carbonyl compound. Now this beta hydroxy carbonyl compounds undergo dehydration. That means these aldol products lose water when they are heated with mineral acid, and finally they form alpha beta unsaturated carbonyl compounds. What happened? This H plus, because in presence of mineral acid, now this H plus occupies this lone pair of electron of oxygen atom. So oxygen atom acquires positive charge, and then what happened? This hydrogen removed as H plus, electron pair shifted here and water is removed, and finally you will get the alpha beta unsaturated aldehyde. Alpha beta unsaturated carbonyl compounds are the usual dehydration product and they are stabilized by the resonance. And these alpha beta unsaturated carbonyl compounds, they have great synthetic importance, because from this alpha beta unsaturated compounds, on oxidation you can prepare alpha beta unsaturated acids, on reduction you can prepare alpha beta unsaturated alcohol, etc. Now this aldol condensation reaction is possible only when the carbonyl compound has at least one alpha hydrogen atom. Therefore, formaldehyde, trimethyl acetaldehyde, benzaldehyde, they don't respond to aldol condensation reaction, because these compounds, these aldehyde molecules, do not possess alpha hydrogen atom. Now, electron withdrawing group on this alpha carbon atom facilitate this reaction, whereas electron releasing group retard this aldol condensation reaction. Okay. Why? Because in the mechanism you have seen that here the carbon ion is forming. If electron withdrawing group is present in the alpha carbon atom, then this carbon atom acquires little positive charge, partial positive charge, so it can easily release the H plus and form the carbon ion. Whereas if this alpha carbon atom is attached with electron releasing group, the reverse effect occurs and this carbon ion is not formed so easily. So, electron releasing group retards aldol condensation. Now, cross aldol condensation. If the aldol condensation reaction takes place between the two same aldehyde groups, same aldehyde molecules, or two same ketone molecules, then that is known as simple aldol condensation. Now the condensation between two aldehydes or two ketones which are different, or between an aldehyde and ketone, is known as cross aldol condensation. Now here we have taken the example, this aldol condensation between two different aldehyde. One is acetaldehyde, one is propanaldehyde. Now, a number of products will be obtained. Why? Because This aldol condensation will take place between these two molecules. Again, aldol condensation will take place between these two molecules. And then aldol condensation will take place between this and this molecule. And between this and this molecule also, the two different products will be obtained. One product, when here the carbon ion is formed, you will get one product. If the carbon ion is formed here, you will get the another product. So, when the aldol condensation takes place between two acetaldehyde molecule, then you will get this product. That means one of the aldehyde molecule from the carbon ion attached with the other molecule. Okay. If the aldol condensation takes place between these two propanaldehyde molecule, you will get this product. And if the aldol condensation takes place between these and this, and if we consider carbon ion is forming here, then you will get this product. And again the aldol condensation between this acetaldehyde and propanaldehyde, but the carbon ion is forming here, then this carbon ion is forming here, you will get this product. So a number of products are obtained. Now Cannizzaro reaction. Aldehydes like benzaldehyde, formaldehyde, trimethyl acetaldehyde. That means the aldehydes which do not contain alpha hydrogen atom. Just reverse of aldol condensation. Their presence of alpha hydrogen atom is must. And here the molecule should not contain alpha hydrogen atom. Then they undergo disproportionation reaction in presence of strong base to form equal amount of alcohol and carboxylic acid. That means this reaction involves the reduction of one molecule of aldehyde to alcohol at the expense of other, and the other molecule is oxidized to acid. Now see here, this is the Cannizzaro reaction between the two formaldehyde molecules. One is oxidized to formic acid, we will get the sodium salt of formic acid, and another molecule is reduced to methanol. Similarly, this is the Cannizzaro reaction between two molecules of trimethyl acetaldehyde, and this is the Cannizzaro reaction between two molecules of benzaldehyde. One molecule oxidized to benzoic acid or sodium salt of benzoic acid, another molecule reduced to benzyl alcohol. Now, this Cannizzaro reaction proceeds through the hydride transfer. Here, one molecule is the donor of hydride, that is H minus, and another molecule is the acceptor of hydride. And that means Cannizzaro reaction is the example of self-oxidation reduction reaction. Now see the mechanism. So this is benzaldehyde. Now alkali, it will attack the carbonyl carbon atom and this pi bond is shifted to oxygen. You will get this one. And then what happens? This negative charge will come back and this hydride, hydrogen with electron pair shifted to another molecule of benzaldehyde. Okay, it is attached to the carbonyl carbon atom of another molecule of benzaldehyde, and then finally you are getting this product. What is that? This is the acid. From here you will get the acid, and this one is alcohol. Okay. Now this acid will release the H plus and this O minus will take the H plus and you will get the carboxylate anion and alcohol. Now cross Cannizzaro reaction. Cross Cannizzaro reaction means Cannizzaro reaction between two different aldehyde molecules. And Cannizzaro reaction between two same aldehyde molecule is simple Cannizzaro reaction. Now, cross Cannizzaro reaction between an aromatic aldehyde and formaldehyde is an important synthetic reaction due to greater susceptibility of formaldehyde to oxidation. Generally, Cannizzaro reaction, if you take one molecule as formaldehyde, then formaldehyde is a strong reducing agent, so it always oxidizes to formic acid and it reduces the other molecule. Okay? And in this reaction, we get mainly the sodium formate and alcohol corresponds to the aromatic aldehyde. So here it is, the Cannizzaro reaction between benzaldehyde and formaldehyde. The question may come, which one will oxidize, which one will reduce? When formaldehyde is one of the molecule, always remember, it is strong reducing agent. It will reduce the other aldehyde and itself get oxidized. So formaldehyde will get formic acid, that is the sodium salt of formic acid, and benzaldehyde will be reduced to benzyl alcohol. Now coming to the answers of other question. Question number 2. Which particular hydrogen atom and class of compounds are referred here? That particular hydrogen atom referred here is alpha hydrogen atom, and the class of compounds which respond to this reaction, that is Aldol condensation and Cannizzaro reaction, that is carbonyl compounds. Question number 3. What is the final product of reaction X? Final product of reaction X is, X means aldol condensation, that is alpha beta unsaturated carbonyl compound. And the last question, what are the products of reaction Y? That means what are the products of Cannizzaro reaction? Alcohol and carboxylic acid. I used to have your comments and valuable suggestions. Watch my previous videos on teaching chemistry through riddles. Also, link is given in the description box.